response question of the day. It says, consider the curve given by 2x subtract y equals 3 plus cosine y for all points on the curve, and it goes from 2 over 3 to positive 2 for the derivative. And then show that this derivative is equal to this to the right. And how could you show that? So we're going to first start by writing down what's given, and then we're going to take the derivative, and it's going to be done implicitly. So I think it might be wise first to distribute. So that's 2x minus 2y, and then take the derivative of what we see. So the derivative of 2x is 2. The derivative of negative 2y is negative 2, but because it's y, it needs a y prime, which is the same as dy by dx. On the right side, the derivative of 3 is 0, and the derivative of cosine is negative sine y, but again, it needs that little hook, y prime. We want to get all the y primes together. So to do that, I'm going to add sine y prime, and I'm going to subtract 2 to the other side. I'm going to divide out y prime, or factor it out, I should say, and then divide. So I get negative 2 divided by negative 2 plus sine y, and if you multiply top and bottom by negative 1, you would see that it would look exactly like that. So did you show that that equation matches that derivative? And the answer is yes, and you did it. Part B. For negative pi over 2 to pi over 2, there is a point on the curve through which the line tangent to the curve has a slope of 1. Find that coordinates of P. So I see line tangent. So if I want to understand that, then I need a tangent line that I'm going to work with. So how would I find that tangent line that has a slope to the curve has a slope of 1? So first of all, take the derivative. If this was going to have a slope of 1, then the denominator would have to equal 2, so that the numerator and denominator would be the same number and they would equal 1. So I'm going to make that equal to 2. I'm going to subtract 2 so that negative sine y equals 0 or positive sine y equals 0, because you can divide by negative 1. And then what angle is that true? At what angle is the y value? It gives me the answer, 0 for sine. So if you think through the unit circle, the y value is 0 at 0. So y is equal to 0 in that case. Next, I need to go back to the equation that was given in question number 6. Now I have a way to substitute in and find the x value. So I'm kind of working backwards. I know this, but I don't know the x value yet. So to find the x value, where there's a y, I'm going to plug in 0. And then I'm going to solve for x. So to solve for x here, I'm going to distribute. Now, the value of cosine at 0, that's at the same thing here. What's the x value there? And it's positive 1. So 3 plus 1 is 4. Divide by 2. And what does x equal? In this case, x equals 2. And that's actually all we're looking for, that coordinate. So what coordinate? And the answer is at 2, 0, that would give you a slope of positive 1 for the tangent line. So we're done. As soon as we know x and we know the y coordinate, that's what it's asking for. It's asking for the coordinates, x and y. And the coordinates x and y would be 2, 0. So it starts off by giving you the slope, And you had to work backwards to find the y value and then the x value to get the answer you're looking for. All right, part C. Determine the concavity. So when you think of concavity, which derivative is that? That's the second derivative. So we'll go back to the first derivative. dy by dx is 2 minus sine y, just like that. So if I wanted to do the second derivative, what rule would you have to do? So you see it's dividing, so you'd have to do the quotient rule. So what is the quotient rule? So it's the bottom times the derivative of the top, that's 0, minus the top, 2, times the derivative of the bottom, that's 0. Now the derivative of sine is positive cosine, but because it's negative in front, it's going to be negative cosine y. But it also needs that hook y prime connected to it because y is a part of it implicitly. And then you take the bottom and you square it. Now, one more step. We're going to substitute in what dy by dx is again, back in. So the second derivative, 0 times this is 0. We have negative 2. We have negative cosine y. And then dy by dx is 2 over 2 sine y. And then the question is, so a negative times a negative is positive 2 cosine y. And if we take this fraction, the 2 would stay in the numerator, so that's really this times 2. And then the denominator, 2 minus sine y, this denominator would join this to make it 2 minus sine y cubed. And then from negative pi over 2 to positive pi over 2, that's from here, negative pi over 2 to here. What would the concavity be for that? So if I look at the x value there, the x value, the cosine here, for quadrants here, would be a positive answer. If I look here in the denominator, 2 subtract whatever sine is, well, the value of sine can only be between negative 1 and 1. Like, it will never be bigger than 2. So that means this will always be positive, and this will always be positive. So we have now found out that the second derivative is always positive. So therefore, from negative pi over 2 to positive pi over 2, how's it defined? It is concave up because the second derivative is always positive. All right, part D. Let f at x be a function defined implicitly, we've been working with that is continuous on that closed interval from 2 to 2.1 and differentiable from 2 to 2.1. Use the mean value theorem. So I need to know what that means. That mean value theorem is when a rock equals I rock, but there's at least one moment. If you know the average rate of change, there's at least one moment where the instantaneous equals that on an interval if it's continuous and differentiable. All right, on that interval. So show that 1 over 15 to 1 over 5, and that's f at 2 minus 1 minus f at 2. So it feels a little complicated at first, but we're going to break it down. A rock, the average rate of change from here. So for that to be it, we're going to start with how to find the slope. So we're going to start there. F at 2.1 minus f at 2 over 2.1 take away 2. That's what this is right here. And if I look closely, and that we know that there's some c value that will equal that in the interval. And that's from 2/3 so I can see the middle part here, f at 2.1 and so on. This part here is 0.1. So what I can do is I can multiply everything times 10 to undo it. So point 0.1 is the same as 1 over 10. And if I want to undo it, I could just multiply everything times 10. From 2/3 to 2. You got this. So 10 over 15 is 2/3. So this is what we're doing. So the 1/10 means the same as if you do the reciprocal times 10 to everything. So we're not doing times 10 to this. We're doing times 10 to this up here to make them equivalent. So if I multiply everything times 10 here, 10, 10, 10, it will equal what I did down here. So we have 2/3 this whole thing times 10, and then 10 times 1/5 is 2. So that's where 2/3 and 2 come from. Then, if I divide everything by 10, what I see is 2 over 30 and 2 over 10. So I see 1 over 15 and I see 1 over 5. And I show that that is equal to that, the A rock and the I rock. This is a convoluted question. But what I do want to get from this is that when you see mean value theorem, do you know what it means? Can you set it up what the mean value theorem is and then work to the best of your ability to do what it's asking you to? So I think this is a challenging question because of the number sense and not the calculus part. So that's why I think it's maybe a bit of a silly question to throw in, because it's really the number sense and not the calculus that's the problem here. So I'd much rather you just see a calculus question to know what you're doing rather than the number sense and the fractions and all of that. But looking at A, B, C, and D, it's the ability to understand what a derivative is, A rock versus I rock, tangent line, all those good calculus concepts up to D anyways. Mr. G Math, over and out.